today we're going to take a look at a dihybrid cross. Di meaning two, so we're going to look at a trait controlled by two genes. Now, the first thing up there at the top, this activity is based on the eye color calculator. That is a really cool website that kind of goes over this. Unfortunately, the website is broken right now. I leave that link there because I keep hoping someday it'll be fixed, but that's why that link is there. So, a Punnett square can be used to predict the genotypes and phenotypes of the offspring looking at traits controlled by one gene. A Punnett square can also be used to look at traits controlled by more than one gene. Eye color pigments, which are your melanin, so that's the protein that controls the color of your eyes, your hair, your skin. The eye color pigment is controlled by at least two genes and are additive, meaning they build upon each other. Blue is the least amount of melanin. Green is slightly more melanin, so kind of a yellowish, orangish kind of shade of melanin, which on top of blue shows up green, and then brown is even more melanin. Capital B codes for the most melanin, so brown. Capital G codes for slightly less melanin, so green, and the recessive of each, so lowercase g, lowercase b, both code for a very small amount of melanin, for blue. Obviously, if you get a capital B and a capital G, more melanin is going to show over slightly less melanin, so that's the additive aspect here. So let's look at some examples. The father has brown eyes, the mother has green eyes. And so I gave you an example where we've got the dad is heterozygous for brown, and then he's also heterozygous for green, but it doesn't matter. If he has one capital B, he's going to show brown eyes. In order to show green eyes, the mom has to have two recessive Bs and then a capital G. And so she has green eyes, and then she's got a recessive allele also. Now, in order to fill out our Punnett square, we've got to figure out what two alleles each person can pass on. Now, before, it was just a matter of put one B over a box and put one B over a box. Well, now we've got to give a B and a G at the same time. And so, this dad could give the capital B with the capital G. He could also give the capital B with the lowercase g. So we've got those two examples. He could also give the lowercase b with the capital G. He could also give the lowercase b with the lowercase g. So you can almost think of this like algebra when you are foiling and combining all of those. Now, the mom has lowercase b, and she can give that with a capital G. She could also give that lowercase b with a lowercase g. Now, she could give the other lowercase b with the capital G, but that's exactly the same thing. She could give that other lowercase b with the lowercase g, but that's the same thing. So we're not going to be repetitive. So, taking a look at this, we've got capital B, capital G. We've got the next one, capital B, lowercase g, lowercase b, capital G, lowercase b, lowercase g. And then we're going to do the same thing over here. Now, because the other lowercase b capital G is going to look exactly like the first, we don't have to fill that one in. Because the other lowercase b lowercase g is going to look exactly like the first, we don't have to fill that in. So we're actually only going to fill in half of this Punnett square. And so, as I fill this in, I want to put capitals before lowercase, but keep all of the letters together. So keep my B's together, keep my G's together. It's going to make it so much easier to read this if you don't start mixing B's and G's. So capital B before lowercase b, but all the B's before the G's. And so I'm going to continue filling this in. And then you get the idea. Now, at the bottom, what are the possible genotypes? So these letters are the genotypes, and phenotypes for the children. Now, there are only 6 different ones. Notice you're going to fill in 8 boxes, so there are 2 that will be repeated. And so let me just do an example for you. Big B, little b, big G, big G. Doesn't matter what any of the other letters are because there's a capital B, it's going to be brown. So I'm going to write the genotype and its phenotype. Oops, I realized I forgot to finish that one. I'm going to do this one as an example next. We've got little b, big G, because there's no brown allele, it's the recessive, then the green is going to show up. Okay. you will finish the rest of that up on your own. Let's look at the back side. Okay. Based upon your phenotype and those of your parents, attempt to determine your genotype. Flip a coin for alleles that you don't know. So let's say that you have brown eyes. Well, you know that you have to have a capital B. You don't know any other letters. Now, if you know for a fact that you have a blue-eyed parent, you know that parent only gave you recessive alleles. And so you could assume that you got a lowercase b and a lowercase g from that recessive parent. And then you'll flip a coin to determine what that allele is. So heads, it's dominant. Tails, it's recessive. Now let's say you don't have a blue-eyed parent. Maybe both of your parents' eyes are brown or green. And so therefore, you don't know what they gave you. So you're going to have to flip a coin for all three of those. Let's say you have green eyes. To have green eyes, you know that you have to have two recessive B's. You have to have one dominant G, and then you'll flip a coin for that fourth allele. If you have blue eyes, nice and easy. All of your alleles are recessive, and so you don't have to think about it too much. Then I want you to the right to write down what combinations of alleles you could pass on. So is it, big B, big G, little b, little g, whatever it is. Now, I forgot to specify, when you are doing this, you can only pass on a B with a G. You can never pass on 2 copies of a G. You can never pass on 2 copies of a B. You pass on one or the other, but you never pass on 2 of the same letter at the same time. Okay? Coming back to the back side, my partner, pick a partner. It could be your mom, your dad, a sibling, your friend, and ask them their eye color, and do the same thing to figure out their genotype. And then depending on how many different combinations each of you have, maybe you have 1 combination if you're blue-eyed, you got 4 combinations because you are heterozygous for each, fill in as many of those squares as you need to, and then fill in the genotypes and phenotypes of your offspring. And one thing I forgot to mention up here, as you're determining your genotype of your eye color, if you have hazel eyes are really challenging because that's actually controlled by another gene, and they don't fully understand how hazel eyes work. And so you may choose what color eyes you want to consider yours. What color are your eyes most often? Of course, if you have any questions, don't hesitate to ask.